Hello, Maurieo. In this video I'm going to take a little bit of a look at a traverse that we did today. We encountered a few problems with the height, but along the way we got a pretty good bearing close, and coordinate close was pretty good as well. So first off, let's have a look at a diagram of the this is our overall picture or diagram of the traverse, a bit crowded there with the text and that, but we'll zoom in and have a bit of a look at things. But first let's have a general overview. Essentially the traverse went from peg 1 to peg 2 in here, peg 3 here, and peg 4. That was our closed traverse. We had an origin out to a nail OR here, which we measured with the compass, and that was our origin of bearings, which we then used that as the origin of bearings, but held the bearing between peg 1 and peg 2 that we observed after holding that origin in place. Nail OR here is also the origin of coordinates. So we're working on assumed coordinate assumed coordinate origin, assumed origin of heights, and assumed origin of bearings. Now at peg 1 and at the other ones we had a few little things to pick up. So B1, B2, B3, these are a line of bollards that sort of define the physical boundary of the where we're working. So we picked up all the angles in those bollards, and then along the way, so we picked up some of those were picked up from peg 1 here, and then other ones of them were other bits of the bollard were picked up from peg 2 here. Previously we had done with our leveling exercise that we'd done, we had run a cross section from SN02 to SN03, so we picked those up, and so we had some heights on those from our leveling traverse that we'd done. We also had some other marks that we've had levels on but not good positions, APKR here, APKR again here, and peg HL, which is up here, peg HL here, and we also noted that there was a boundary peg here. So we took hanging lines from those, or pegging ties from those, from the various marks where we could. We also took the opportunity just to run these cross sections here using topo shots. So our pegging ties were, as you'll see, were done on face right and face left, and our topo shots just done on face left, and they're done here. So the idea was to do two cross sections of this little piece of an existing bit of road that runs through here. So I've just drawn two cross sections here and joined up the curb lines. So two different templates or curb templates used. This one here has a channel, and this one doesn't. Mountable curbs basically. With this one had a little bit of a channel, and this is the centre line of the road. So that's our traverse, how it's all sort of drawn up to scale there using a bit of survey software. Now we did this work in the field using written field notes. So everything was done in writing on the field notes, and although we used total stations that were capable of keeping or storing the data, we didn't. We wrote all the data down, left and right face, and our differences in height. Now what we did was we kept on the instrument when we were using it, we kept the target height equal to 0 and the instrument height equal to 0. But when we reduced the heights, we found that we got quite significant differences between one way going from, say, peg 1 to peg 2, and from peg 2 back to peg 1. The differences were greater than you would expect as curvature and refraction. So we'll have a look at the I then transferred the field notes, or copied the original field notes into Microsoft Excel spreadsheet, and we'll just have a look at that now. So this is our Microsoft Excel spreadsheet here. Just to get you into the picture, this is observations here from Peg 1, from Peg 2, Peg 3 and Peg 4. So let's just zero in a little bit here by increasing the size of this here. Oh, what's gone wrong there? Damn. Got a bit of a problem there. We'll just stop and I'll just see if I can sort that problem. Okay, here we are back again. Everything fixed up. So here we are at Peg 1, and I've just shown the normal sort of situation that we did here. So we started at Peg 1 and we observed nail OR, which we used as our origin, but we actually found that we're going to I've just fixed that up. We actually found that we're going to hold this bearing here of 140 degrees 3817 and the one to the nail, this one being internal into our circuit to Peg 2. So obviously we go through and we started at Peg 2 to nail 04, and there. We then moved on to Peg 2 and observed to Peg 3, and these are the main points of our traverse. We then went from Peg 3, observed back to Peg 2 and forward to nail 4. When we were at nail 4, we orientated on Peg 3 and observed through to Peg 1. Remember that the black is what we filled out in the field, the green are our subsequent calculations and things that we've done in the office with regards to the bearing close, and the red are our final adjusted bearings and distances. Bearings and distances, as it turns out. So when we got to nail 4, we observed back to Peg 1 and we got 11 degrees 5013. However, when we were at nail 1 and we observed to nail, when we were at Peg 1 and we observed to nail 4, we got 198.4812. So what we do is we bring our reverse of 11.48.43, which is, sorry, a reverse of 11.50.13. We bring that up here as 191.50.13, and this is where our 2-minute bearing close or misclose manifests itself. Now the way that we show that is, or the way that I show it, there are many different ways of doing it, is that I apply that 2 minutes 01 to our origin line here. Just bring that across to there as a sort of orientation correction, if you like. So if we add 2 minutes 01 here, we would have to add 2 minutes 01 here, and that would give us 140.40.18. But of course we are holding that line, so that gives us the sign of our bearing correction here, whereas we're adding here. This here tells us that we must subtract 0201 to get our held bearing here, which is 140.38.17. So that straight away there is where our bearing correction manifests itself with the correct sign, which is minus 0 degrees 0201. Now as we can see here, we have got 4 setups and we've got 0201. So if we work that out, we can see, or divide that by 4, we get like 30 seconds. 4 times 30 seconds would be 2 minutes, and then the 1. So we'll subtract 31 seconds at Peg 1, and then we'll work our way back through. Obviously we started at peg 1, came forward, so we apply our correction back through. So we're going to apply 31 seconds at peg 1. So if we've got minus 0201 here, and we'll take off 31 seconds, we're going to have minus 0130, which is going to be our correction here. So we've applied 30 seconds there. You can see that the net effect of what we've done here is 0. We've effectively applied 0 there, and if we've added that and subtracted that, we've effectively what we've effectively done is applied 30 seconds there, and we get 91, 48, 43. So we're just going to deal with the closure first. So that comes right back to here, and of course we would apply the same correction to the bearing there, and then another 30 seconds to the angle here, which makes that one minus 0100, and we can see that that gives us 128.0714. And then we work back here. Of course that's minus 01 there. If that's minus 01, that's minus 01. And then we apply another 30 seconds here, 54.18.26, to give us, take 30 there, so that gives us that one. And then we're back up here to peg 2, where on the same line the 30 seconds applied, and then of course 320.38.17, we're applying 0 there. So that's our bearings closed. So what we want to do now is we want to reduce our bearings. Now 30 seconds over the length of these lines here is not very much. It's only a few mils here or there. If you look at my bearing rounding video that I've just done recently, you'll get a good handle of that. So 30 seconds over these very short lines doesn't amount to much, and it's sort of what you would expect, especially with this sort of traverse, which was not forced centering, where we were holding and observing poles, so we could have pole error, a little bit of shake as we had sort of novice pole men and what have you. So let's just tidy up the bearings. So we've got our bearing closed there, and then we just round these up. Now to the nearest 10 seconds probably is fine. 320.50 there, and 140.38.20 there, 191.48.40. Now for these are our what I call our pegging ties. These are largely unchecked. We have done face left and face right on these, so they do have a little bit of a check, and we've measured them twice, but ideally we would like to do some form of other independent check, but we haven't in this occasion. That's going to be the next lesson. So we're just going to show the bearings to these to the nearest minute. So as our net change here is next to nothing, 328.15, 328.23 and 319.30 there. Okay, moving on to peg 2. If we look here, the net change there on the actual orientation, we've nothing there, 30 seconds there, so I think we can pretty much leave these. There's no need for any further adjustment. 271.52, 110.53 to the nearest minute, 131.26, nearest minute, nearest minute, nearest minute, which then brings us to peg 3, and we've really we've applied 30 seconds there and a minute there. So I've usually chosen the back side and said, well, let's apply 30 seconds there, you know, just to this here, and then we round that to the nearest minute, so that would be 312.10. There's no real big issue there. We don't need to go down to the nitty-gritty of seconds, because we're only going to show them to the nearest minute. Now here obviously we've got nothing, we're all done. It's just a little closing shot there. So let's move on to the distances. What I've done with the distances, quite simply, we've just taken a mean of the distance, taken a mean of each one, and then we've taken an average where we've measured a distance twice. Now out to from peg 1 to nail OR, we only measured that in one direction, but from peg 2 to peg 1 to peg 2, we've measured it in this direction, 147 0.145, and we've measured it in the other direction, peg 2 to peg 1, 147.13. So we just average those out, make sure that they're the same value, average those out. And then similarly with all the others, 35.99. And with our other distances where they're not part of the Travis network, we just average them out and show them in red. And then of course for each little setup there should be a diagram which will show, you know, roughly where the bearings and what have you go, so you can sort of draw them roughly to scale, so you've got a bit of an idea and a bit of a picture, show your bollard line and road lines and things such as that. And also when we observed, we did most of our topo shots, so our bearings were reasonably okay for the topo shots, that we didn't need to apply any correction. So now we come to the heights, and we had a bit of a problem with the heights. Essentially, how we work out the heights here is these are the differences in height that we measured, face left and face right. Now what we do is we actually mean those, and I have done it slightly, we mean those, but we also need to, because these are from the instrument to the target, we need to account for the height of the instrument and the height of the target. So what we do is we take the mean of these, well, let's perhaps start with the height of instrument. So we take the height of the instrument, we add the mean of these two here, whatever it is, algebraically, if it's a negative or a positive, so we might add a negative or add a positive, and then the mean of those would be that plus that divided by 2, which I've indicated here in my formula, and then we subtract the height of the target, which we've recorded here, and that gives us these values through here, which are the difference in height. Now some of these values are like this one here is only one way, but some are in two directions. So if, say for instance, we were to go from here, we go at peg 1 to peg 2, and we've got 0.353, and I've recorded them down here as the raw ones. When we're at peg 2, looking back to peg 1, we've got minus 0.230. Now we would expect that there would be, you know, one would be positive and one would be negative. That's not a problem. However, they are quite considerably different, and I'm at this stage I haven't been able to find out the reason for that, and it's under investigation. But how we're going to deal with it in this situation, and this is what I've come up with. It's not ideal, but it is a solution, and it seems to have a good fit. But definitely I would recommend that we sort of had another look at the heights. We could possibly go out and actually just do a level run around the pegs just to see if we can sort out the height, and we need to spend some time looking at our instrument just to make sure that we can sort this issue out. But in the meantime, and with this data here, I've just come up with this solution here. So what I've done is from each of these here I've recorded, I've just recorded the actual, I'm just fixing things up here now for these spreadsheets have a habit of getting things in there. So I've just recorded them all here. Now what I found was that if I took the mean of them, like if we added up the raw ones in one direction, the raw ones in the other, we would expect that they would sum to 0 because it's a closed circuit of heights, but it doesn't. It sums to 0.154 and 0.147. But when we take the mean of them, like so, we get a sum of 0.03, so they close up quite good. And so what I can do then is I then applied a correction to make that sum there, to make them sum, you know, as correction, to make the sum equal to 0. And so you can see here I was then able to work out some heights here for this here. Now and these here would be the actual heights that we've got here. But we seem to have, as I've worked out over here, that this is the difference, or the raw value minus the mean sort of type thing, or the difference. This is raw minus raw actually here. So I've taken out the two raw values there, and that's got in capitals. I've put the two raw values in, so the difference between the two is 0.123, and that might, halving that, or that's raw minus raw divided by 2, gives us the idea of the sort of error that is in each of the calculations. And you can see there it's got a little bit of a around about 0.038. Now I've also realized that some of these marks we had heighted using the in our leveling exercise that we did. So we had heights for some of these marks. So what I did was I came down here, particularly at peg 2, and I had a look at the ones that we had the heights for, and tried to make it so that we had very little correction for those. And so what I was able to do was to just using those, work out what sort of correction we should be applying. I'm sort of quite happy with the corrections between the marks, like so, and working them out. But first of all, I had to get some sort of correction back to nail OR here. So I came up with this correction of round about minus 0.05 there, which I applied to there, and that with the difference, this is applying to the difference in height in one direction, because you can see that although the mean's okay, each of these raw values needs to have this correction of this magnitude applied to it. So by working back from some of the ones that I've got here, I was able to come up with this correction, which seems to make everything fit quite well, and I've recorded it here, and I think you can possibly use this. So it's just a little correction here, and what I've done is where we have values that we know, I've applied the correction. So for instance, here at in this one here, the 353, we know that the 0.062 we can apply, and then that'll give us our mean difference in height. And then we've got to try and make that fit some of these values that we had over here in peg 2. So a little bit of mucking around there, and I've come up with a solution. Now for some of you, this might, understanding this solution might well be a step too far at this stage. So I'm quite happy to help you with it. But what I suggest you do in the meantime, with your data and the way that you record your data, what I suggest that you do is first of all get your bearings sorted, get your distances sorted, and get your heights worked out to the point where you can at least get these raw values, the raw values here, okay, which would be this value, these values here that I'm pointing to here. So get those raw values in place, and then you can come and see me, and we can do a little bit of work and see if we can work some things out. So you may have to adjust your field notes a little bit, but that's what I would suggest you do. At least get them to this stage here, and then we can come and have a look at them. And in this case, I think the guys did particularly well in that their heights, the error in there is this far unexplained. It could well be a setting in the instrument or something like that we've sort of overlooked. But we've come up with a bit of solution here. Not an ideal solution from a surveying point of view. I would definitely, from a surveying point of view, recommend that we would go back out and check the heights. But for the point of this exercise, I'm going to leave it at that. So hopefully that'll give you a bit of a starting point, a bit of a heads up, and you will need to come and have a chat to me if this problem comes up. If you find that your raw values and your two raw values are roughly similar, just meaning them's going to be fine. You're not going to have any problems, and you should be able to just work backwards. But it's unfortunate in this case that we seem to have this little problem. We've talked about it, had a look at it, and this is a solution that could work. And as I've said, with this whole particular assignment that we're doing, it's all about communication. So this group of guys has come and seen me. We've talked about this, and I said I'd have a look at a solution for them. This is a solution that I've put up. We've still probably got a little bit of work to do on this one, but we're making progress. So guys, you know who you are. If you want to come and see me and have a bit of a chat, that's all very good, but all well and good. I'm sort of waiting by the phone. So cheers and good luck, and remember, you only have to ask if you need a bit of help with this one. Okay, all good. We'll just put that back to maybe drop it down a little touch. I don't know if that makes it any the more readable or not, but we'll see how we go. This is Maurieo signing off. Good night and good gardening to you all.